right, welcome everybody. Tonight is the 22nd of March in Dallas, and we're going to have the normal Robot Builders Club Builders Night Out, hosted by the Dallas Personal Robotics Group. And we'll just go around the table. We've had a kind of a pre-discussion starting off already before the recording on ROS 1, ROS 2, and a handful of practical matters. So I'm going to suggest that we just continue on. It sounds like there might be a little bit of a wrap-up from that, perhaps. Maybe a little follow-on discussion. After that, we have in queue, we have John G. and Paul B. and then a free-for-all. So Ross, you did a great job of kicking us off on ROS on ROS. So was there anything you wanted to summarize about that?
I guess I didn't get a chance to grill Harold when he chimed in there towards the end. I was glad that he did, because I don't know the background of his project, but he said that he was using ROS 2, and I was wondering like what made him do that, because like I guess from the outset, like I'm seeing that a lot of people are either trying to transition from 1 to 2. And I'm thinking like, well, if I'm starting a new project and I want to put the sweat equity into learning it, should I learn what's out there full of tutorials, easier to learn, but is gradually, people are gradually moving away from, or should I, go into ROS 2, which is a little bit more newer and
The short answer to the question is ROS 2, new hotness. ROS 1, old, not necessarily busted, but I want to learn the new stuff, and if this is where it's going, and I think that is where it's going, even though as other people have said, by far outweighs the number of users and implementations than what ROS 2 has got going on. There's just some things that they don't want to transfer over. A lot of things we talked about stuff with the ROS serial and the bridging thing that goes on, and all the other nodes that have already been developed for ROS 1. They can't work in ROS 2 unless you do a bridge thing, and that gets a bit unbeginnerish, so to speak.
Mm-hmm.
Yeah.
Ross, my understanding, which is limited compared to others here, ROS 1, basically they did what sort of like what Murray's doing out in New Zealand, which is they wrote their own messaging bus, their own data distribution system. And in ROS 2, they moved to OpenDDS. Actually, you can use, their interface allows you to use a bunch of different data distribution systems. But
yeah, I've seen that.
So now you have, if Murray was here, I would suggest it to him, because basically Murray's writing operating system stuff in an interpreted language in Python. And if you go to the DDS, that's all written in C. It's all real tight and runs real fast and is real heavily documented. The downside of that is with OpenDDS or any of the data distribution systems, if you've ever looked at them, those are complicated. It's not a trivial sort of thing to set them up and get them running. So what ROS 2 has tried to do is sort of hide all that, make some assumptions about how you'd like to use it, and then hide all that behind the ROSness of it all, so you don't actually have to interact with that very, very complex but very powerful data distribution system. And I think the reason that was done, well, what I've read, the reasons that were done is that despite the wide distribution of ROS 1, there are a lot of complaints from the users about problems with it being optimal for robotics. And the data distribution system, or OpenDDS or one of those, kind of moves it into a more industrial framework. And that's like big factories, that's the way the stuff talks to each other and so forth. So
yeah, the timing on the ROS 1 communication is, it's just not controlled in any fashion. There's also high overhead. So I think that was just not a lot of real-time capability there in the way they were doing the communication.
And as far as robotics and stuff goes, I mean, we have a bunch of async things. We have a bunch of things that happen all over the place. And with ROS 1, you have a centralized master that controls all of that communication. ROS 2 gets rid of that master. So every node sets up the network, so to speak, as it comes in. And as more nodes join to it, they just see more things that they can do and talk to. So it makes it so I don't have to go through a master if I want to talk to the GPS node or I want to talk to the other node, to some other node. I can just send that, I can publish something into its topic directly. I don't have to go and waste time going through something else, and all it is a traffic director. There's a lot of
So Harold,
there.
in your project with ROS 2, are you running an RTOS of some kind, or are you running it on bare metal?
No, what I'm doing on this is I'm making my rover, trying to make it smarter where it could do all the things I wanted to do last time and actually GPS around and recognize stuff. And so I just ran into some DLL hell pretty much with the ROS 1 and the requirement of Python and the various bits and pieces. I couldn't get some of the data ingested and different versions of Python that I needed, and then push it out. And then, well, I could do it in C++, but that version is not supported with what I need to get going, and I could backport it, but I'm just not going to do all that. That's just too much work. And there's nothing. Well, I say it's not too much work. It's a lot of work, and at the very end of it, I'm still going to be behind the curve of all of that stuff. So, which is why I went with the newest stuff I could do.
But are you running it on a microcontroller?
I'm running on a Raspberry Pi 4. I'm running on a Raspberry Pi 4 in a Docker container.
Okay.
You're welcome to go use any and all of this that I'm doing. I mean, right now, I run through most of this stuff on my stream on Mondays and Fridays. Tomorrow night we'll be doing something different, but on Mondays and Fridays on my stream, I've got ROS 2 working. I've got people helping me that they don't know very much about a whole bunch of other things, but they know how to code and do other things and cheer me on and all that kind of good stuff. And we're figuring some things out. And if you want to come see and how I'm working on it, just join me on my stream Monday and I stream Monday, Wednesday, and Fridays, 8 to 10 Central. Easy peasy. Show up. Well, Mondays I had to move them to 8:30 because it seems Taiwan doesn't want to shift its time zone and or anything. The whole Taiwan doesn't do that, and so our 6:30 to 7:30 meeting changed to a 7:30 to 8:30 meeting in the whole thing. So, but there you go. And of course, there's a lot of hemming and hawing, a lot of joking around and other stuff there too. So whether that's your thing, but you can see it working and you see how we're doing it, and then you can make your own decision.
Everything that the previous speakers have said about ROS 1 versus ROS 2, I think is right on the mark. But there's another aspect of it that I think is worth pointing out, which is that not only did they change the transport, but they changed a lot of the infrastructure in terms of build infrastructure and tooling. So there's a completely whereas ROS 1 uses cat can make that's built on top of CMake. ROS 2 uses some different
Qualcomm, I think.
Yeah, Qualcomm. And there's no launch files anymore. ROS 2 uses like plain old Python scripts, and that has a
I mean, it is a launch file, but you can use the XML if you want to, but they're really pushing that you do Python. And I've been looking at this the last few weeks, and there's some really cool things with the Python that you don't get with the XML. For instance, if I wanted to fire up just one subsystem, I can make that one launch file. And then if I wanted to fire up another subsystem, each subsystem could be its own launch file. And then I can have another launch file that includes all these other launch files, because they're just objects that you get to import from one object and use in another object. And so you can compose what you actually want to debug and put together at a time. So it's actually really pretty cool, but it is different than the ROS 1.
But they don't use, specifically I was referring to ROS XML.
No, they don't use ROS. I mean, no. Right. There is. I think there's an XML fashion that you can use, but it's not the same as ROS 1.
Yeah. So my only point is they're very different environments. So speaking further to the point of should you try and do both side by side and
No,
have
no,
some
no.
kind of bridge, you're doubling your environment learning curve if you try that one.
No, no, I was simply referring to the capabilities that some experimenters were doing in some of the deep dark realms of the blogosphere out there. It was just interesting to hear that what Harold was talking about, having the Pi. It doesn't talk directly to the microcontrollers. It talks to
A container.
a container. That's
Mhm.
but the microcontroller is being controlled by a bridge that you wrote yourself, like a serial.
No, no. I don't have a microcontroller working
Oh, I see.
now. It is coming though, and at that point, I think the solution to that is like your micro ROS, or they've got a couple different solutions. Whether I use it or not, I'm not sure, but that piece is coming down the pipe. I will tell you that the way I've fired up the container is a little special, meaning I made it privileged so that the container has all the access to the hardware as if you were running en route on the Raspberry Pi itself. So you don't have any of that stuff on. I also use the host network. So normally what will happen is when you fire up Docker, you get your own network, and that network has a virtual switch inside on your whatever's hosting it to do stuff, and it makes some of the networking hard. But there's a switch in there to say, okay, no, I want you to use the host network. So this container is running as just literally a bucket inside the Raspberry Pi, and it's using. I'm really using it to be a container for all the stuff. So if I want to change out, I don't have to keep installing or deleting things from the Raspberry Pi if I want to change out what I'm doing underneath the ROS. And the other thing that I do is that I've got I mount volumes. So I've got the GitHub, I got a Git repository running underneath. I've got, and then the directories, I have the container, because every time you kill the container and restart it, you lose everything you did in it. So what that container does, it sits there and then mounts file systems from the host to find all your nodes and all your Python stuff and all your bits and pieces. And then you're actually compiling and stuff in the container. And when you're saving, you actually save outside the container so that you can save that in GitHub and save all your stuff you got going on. It's kind of a not convoluted, but a little bit of a elaborate setup. But once you get it set up, it's just a couple of commands. You don't even worry about it. Works pretty good. Works good so far. I've not found a reason not to do that anyway.
I think I'm going to have to join you to watch your workflow, just to see how that goes.
Come hang out. I don't mean to be using this as advertising my Twitch channel or whatever, but come hang out and watch it. And if you got questions, ask questions. Because I'll be right in the big old middle of it, and that's what I do. Is I answer questions. People ask, well, why would you do that? And we get in the whole sub thing going on. We squirrel away with everything up, and he goes, oh, wait a minute, we got to do raw stuff. Oh, that's my babies. I got some other talking to do. I'll be back in a minute.
And just like that, he's gone.
That's how we are these days, right? Shiny object. And I encourage you to jump on his Twitch channel. Just quick show of hands. How many people have actually jumped on a Twitch channel and watched it? Okay, I encourage you to do it just for the experience once, because it's not what I would have expected. Harold, I was in one telling and then remarking that they should at least visit a Twitch channel at least once to see what it's like, because it's a different experience from my point of view.
It's different. And by the way, the shiny object was the wife that's been away for the last couple of days. So, yeah, I put my my Twitch channel and the link in it in the chat. And Carl is exactly right. You can get on there and you can find lots of things. Some of the things are really, really wonderful. Some of the things, like the hot tub channels, probably not so wonderful from what you're looking at to want to spend your time on. And most of them are going to be gamers around gaming, that kind of stuff. But I've got several of them that I run around to, watch them, and they're fantastic as far as the electronics and stuff. We got everything from people rebuilding old audio electronics and soldering stuff all the time to other folks like Bald Engineer that's rebuilt an Apple II on a watch and still working on that and repairing stuff and those sorts of things. And they're lots of fun, and a few maker spaces show up in there. We're definitely the niche in that zone. We're not the most popular of all the stuff that's going on there. The really big things are all the gaming and gamers and that kind of stuff.
Robotics is not the most popular.
I know. I hate to break it to you, man.
At least the drones.
But there is a robot out there. There's a channel out there, the robot that I forget, it's one of those, we've talked about it before, but it just sits there waiting for people in chat to type in instructions to have it run around the table and do stuff and park itself and that kind of thing. And that's just of course that gets more subscribers and more attention than I get. So I guess along with that, and the duck pond that has no ducks usually has more subscribers and followers than I do. So I figured I'm at least as exciting as a duck pond without any ducks, but maybe not. Oh well. Yeah, come see me. Right. And like I say, the main project is the rover, and that's making it smarter and all those sorts of things. And that's on Mondays and Fridays. And the other project you may be interested in or not, it's called a Mr. Big Head. It's like a magic 8-ball that we're trying to make smarter. It interacts with chat, and we're doing a bunch of coding and things on that and going through seriously RDD, resume driven design going on this. It's everything from the hardware all the way up to the front end. This is Blazor, and it uses Azure and Azure Tables and Azure Functions and cognitive services and all kinds of stuff. And did I take over? I didn't mean to take over your stuff.
Use the most stuff to get the least accomplished, right?
Yeah, something like that. It's more like the resume driven. These are things I want to play with and want to do, and I don't have a current position that's going to pay me to do them, so I might as well do something fun while I'm doing the things. And let's make a Raspberry Pi talk with a push a button, or you ask it questions in chat, and it gets pretty snarky sometimes. And then I make a web page on top of all of that that'll eventually allow you to control all the sayings and moods and types. And then we're about to do some things tomorrow night, which may make it really cool to add a bunch of commands, like being able to change his mood from inspiring to dad jokes to wherever, to get up in this. There's a lot of fun stuff going on there. A lot of fun stuff.
So it's Mondays and Wednesdays?
Mondays and Wednesdays is the primary project, and that's going to be the rover. The secondary project will probably switch out over time, because I want to keep it focused mainly on robotics and making things smarter and going further and faster and understanding more about the world and taking knowledge you programs here give me, so that and use it and share it out to I can't say share it out to the masses, but I am pulling about an average of about 5 people per session over the last 30 days, which I've for our subject matter, I think it's pretty good. And the whole scheme of Twitch, where you got people that their average viewer count is 8,500 over the last 30 days, we're not doing a whole lot there.
And it's not TikTok, so we don't have to get you dancing around on TikTok.
Yeah. You don't need to be. No one needs a TikTok. No.
You're just gonna have your
I
boss
have
doing
met some
something
people.
viral.
I have met some people like the Las Vegas Makerspace. I know those guys. I've actually been out and seen them when I was in Vegas last time, and hanging out. And there's some great people doing mostly marvelous things, and some people are just doing wacky things like, I don't know, I'm making lights flash, and I was watching Kitecrafter last night, and he was picking up, he's making a crane so that you can type in something in the chat, and then the crane will go down and pick up some candy out of one of 3 or 4 buckets, and then go over and drop it down a chute so he can have some candy to eat. That kind of stuff, funky stuff. It's just goofy. I'm doing it because I want to learn stuff, and I'm inviting people into my garage. Other people are doing it. I have no idea what they're doing, and the gamers, some of those gamers are making some serious cash off of this. Serious cash. Oh, and I'll do one more push on this. If you have a Prime, membership for videos and all that kind of stuff, you can subscribe to any channel you want for free, and the creator gets a couple of bucks a month off of that. So come by my channel. I put the link. Put the link.
That's with Twitch, right through Twitch.
Yeah, and Twitch. Yeah.
But it doesn't show up inside Prime, or do you have to somehow go to Twitch and then link your Prime account to that?
No. If you're logged in, I forget how you go through the Twitch thing and it's connected up. But Twitch and Prime are really good friends, because I don't own Prime, so I can't really speak to how it is. But if you have a Prime account, you're supposed to be able to subscribe to the different channels. And what description give you? In my case, I'll let you talk to me through the big head with saying anything you want. Currently, and which is actually kind of cool. But other cases, you get other things and stuff, and people are doing a whole bunch of stuff. So it'd be a lot of fun. Just careful where you go, because sometimes you're going to see something you probably don't want to see. But none of it's crazy, because there's they do have a lewdness policy, so you can't really do that. But it still doesn't mean there's things you can't unsee.
All right. Well, on that topic, so I think next in queue we had John G. Are there things we should see or things we can't unsee? I think you were next in queue, John.
Is that question to me?
Yes.
It is a really lame attempt to direct a question to you.
Okay. Well, there's nothing lewd about this presentation. My Halloween project is pretty close to being ready for prime time, way ahead of schedule, obviously. So I've got a face here to follow on a stick. So,
Excellent.
so I don't know if how well you can see it, but
Follow the idiot. Huh? Yeah.
you can see his eyes
Yep.
tracking the face. Probably have to go
Are his eyes rolling up into the
full screen. So I got three modes. When the face is far out, I use the size of the box that it detects around the face to determine the mode. So if it's at a certain distance out, it's just kind of what I call relaxed and tracking with the eyes. When you start to get closer, the eyes start to narrow. I'll call that suspicious mode as the eyes narrow, or the eyelids narrow. And then when you get close enough, I've got a startled mode. So as I move the face closer here, you might be able to see the eyes start to narrow. It tracks my real face better than it tracks this printed face. I don't know why. Did you hear that?
That's fantastic.
Yeah. So the idea is you got somebody come up to Halloween and go, "Oh, this is cool," and they get in close to see the detail on the face. And then,
Okay. I'm going to tell you right now. That's a robot. The mouth moved. That's a start, and it screamed at you.
Yep.
You got it, John. Excellent.
Very good.
I was hoping to get some real good surprises on Halloween.
Gold star.
That's it.
If I saw that face up close, I'd have the same reaction.
The rest of what I've done, I found a nice pitch black
That's
box that hides all of the backgrounds, and I put a hood over all the mechanisms. So I've got all the wires and the Raspberry Pi and stuff hidden now. And you can't see it well, but I've actually got some diffuse LED lamps here. So when I have it outside, when it's a little dark, The face will be somewhat illuminated. That's all.
Cool.
What did you do for the audio for the stream?
I just went on the web and found some free audio downloads. It took a while because, you know, all those free WAV files that they have on the web, a lot of them are just junk. You know, it's like, oh, I recorded this, and they're usually poor quality and have lots of gaps in them. So you have to search quite a bit. I finally found one that was suitable.
I'm going to suggest that you could probably record your own scream and also throw it in it for a loop so that maybe it detects how often, because the first time a first person jumps back or puts their face in, and then maybe have it like say something really creepy, or you know what I mean, like have a continuation, like an escalation, like you already had with the eyes moving closer, and then it could even just have a
Well, there's
routine
lots
that you would take.
lots of expressions and motions that I can add now. I mean, as gravy, like
Fantastic.
rolling the eyes, you know, or winking and blinking. And somebody suggested I get an audio of Jeff Dunham's goes, "I kill you." I don't know if you've seen Jeff Dunham, this Ahmed.
Oh, yeah.
Because it kind of looks like the skull.
Yeah, that's pretty funny.
On the dummy.
You got to do the Wilhelm scream.
Well, Wilhelm screen, I think I saw somebody played that for me, and it doesn't really have a nice short scream. It has to be very short to get a startle effect.
That's true.
Wilhelm scream is more like falling. This is more like scream at you. That's why I was kind of picky on the WAV file that I wanted.
The aesthetics of screaming.
Yes.
Or you could have the kind of like bait. So not only the visuals of the thing baiting you in, but then also like a.
Yeah, there you go. It says, "Get him, come here."
Hey, buddy, want to buy some Halloween candy?
Yeah, if I can add a couple of pneumatically controlled skeleton arms and I throw them up when he screams, that would be really good.
Where are you going to have it wink? That would be great in the middle of the screaming and everything to stop and wink at him.
Well, you know, they're not going to be there. Well, I guess some of them might be there for long. They're just coming up to the door to get candy. They'll look at the face and they'll laugh and they'll leave. But anybody wants to hang around, maybe I can sit there and occasionally have it randomly do things like that. If it tracks long enough, it'll occasionally blink or wink, or maybe roll the eyes.
Another thing you could do is have a blast air come out of his open mouth, like the air hitting the person. The reaction of that would be.
Green peas soup.
The jaw doesn't move very fast. I might be able to get it to act like it's talking, but it's hard to get it to move that quickly where you can simulate a voice.
Well, even just the brain fills in a lot of detail, right? So even if the jaw is moving a little bit while the audio is going, it might be enough to.
Yeah, it's worth a try.
Yeah.
And David, I didn't use subsumption architecture for those 3 modes. It was a little too primitive for that.
Well, it can always be improved. You know, if you're talking slowly, if you were saying something like, "Hey, you," then that could be slow jaw motions. It's probably a matter of picking the right vocabulary.
Well, if I add enough behaviors and more actual inputs to control the behaviors, maybe I'll have to go to subsumption architecture.
Or could you have the jaw, the further down it goes, the louder it is, have it just tied to a peak audio level and a servo, so that louder tones open the jaw more. And
yeah, I said, it opens up the whole possibility of behaviors that you can program. But as far as the hardware is concerned, I think I'm pretty much done.
Hey, Dave Anderson, you might have to do some modeling there, like when you do
And the only thing I have left to do is I need to set it up to run headless. I've got a little control panel in the back where I could push a button, it'll launch the apps, and push a button again, and it'll shut it down, and shut the RPI down, so that I can pull power on it without corrupting the card.
Build
Okay,
has a
just-
super speed servo that could do it. Basically it speeds it up by about 3 times. If you want
Well,
to operate the mouse faster.
Well, like I said before, I'm using cheap servos, and I still get a little bit of buzz at certain points, where it
Yeah.
needs some resistance. But hey, it works. It's not so loud of a buzz that it ruins the whole project.
Pretty cool.
Way to go. Gold
Yeah.
star, we're behind you.
I had I worked at a company for a while that built speech recognition technology, and one of the programmers there was working on a driver for animation, and basically they would just take input speech and generate the proper mouth movements, but not for real simulation, but just for like animated cartoons. And basically, as my memory serves, and you couldn't really do this with your jaw, he needed to break things down into ooh and ah with those two, and pretty much. And if you look at animation, that's kind of what they do. Now, having said that, ventriloquist dummies just have the jaw, and they seem to make it work. They seem to make it look like that it's actually speaking without being able to purse the lips.
Well, and since this is a skull, it doesn't have skin or
Doesn't have
muscles.
lips.
Yep,
Yeah.
it's missing the whole lips part.
Yeah, so you can argue that it is realistic to the extent that it could be.
It's also missing the tongue part.
Yeah.
Very important to speech. Yeah.
All right. John, way to go. I think we had Paul. We had you next. And would anyone like to get on deck behind Paul? After Paul?
Actually, I would. I didn't show. I had something to
Oh.
show, a little something to show. It ain't much, trust me.
Yeah, returned by Harold. Okay, that's good. Encore performance.
Or something like that.
Paul, what you got? You're muted.
Paul,
You
you're
got a good
muted.
mute button.
Paul, we can't hear you.
Couple things. Let's see. Are you seeing the gazebo window?
Yes.
Okay. So thanks for the to the good advice. I thought I fixed this. I narrowed the deadband, and I narrowed it too much and didn't realize that. I think I'm seeing here what you described, David, where it would wander from side to side if you got the deadband too narrow. But after the discussion last week, and I narrowed the wheels. The wheels used to be 5 centimeters wide, and it wouldn't navigate properly. It would sort of turn too sharp. But now it's navigating just like right on the money and ends up right where it should be. So this is a 4 meter by 4 meter square. So anyway, I think between the combination of narrowing the deadband and making the wheels skinnier, it fixed all of those problems. And then the other thing, after our discussion last week, we talked about my issues with Mobot on lawn, and how maybe the spinning in place, the rotate in place, really didn't work. So one of the things I did was make a drive and arc program that I envision using for like that. There was 1 meter, 90 degrees, 1 meter radius, going forwards, and then I can do 90 degrees, 0.5 meters going backwards. And the net of that is it turns 180 degrees while moving. In other words, it's not rotating in place, so I shouldn't see the degree of wheel slippage that I showed on the video last week. So that's kind of like a work in progress, because I haven't tried that out on the real robot on grass, because the I've been busy upgrading the hardware, and I wanted to ask you guys what you think. Like, I guess maybe if you pin me to your screen to see this, to see it full screen. I got a BNO 055, and that's going to be a gyro that I'll use for direction, and I kind of got a couple of questions for any of you who've messed with this BNO 55. First, is this too long of a cable? Like, it's I2C, and apparently it and the ESP32 run 400 megabit fast I2C. So I don't know if this is like too long of a cable. Does anyone have any experience with cable lengths like this? It's like about a meter.
Keep it well under a meter.
Meter and a half, maybe.
I would keep it under a meter.
Yeah.
Use shielded wire as tiny as you can get.
Oh, really?
Yeah, because it'll give you less capacitance on your wires, and that'll help your communication speed.
What do you mean, shielded or twisted pair?
Twisted shielded, but the smaller you can get, like if you can get to 24 gauge or smaller 30 gauge, that'll help with your communication speed if you're going with a long wire.
Okay.
Because the wires, as they're twisted, will act like a capacitor.
Well, but that can be a problem, right? If you add too much capacitance to the line, it'll slow down the edges.
Yeah.
So I think what the twisted pair does is it gives a good return path for EMI. So it keeps, because these are voltage signals. It's not like a differential current, like I guess CAN bus or
right. So what would you twist like SDA and SCL with?
I would just twist them all together. So like what we would do back when I worked in the defense world at TI, and we had to make twisted cable, is we would just take however many wires we had and lock one end in a vise and the other end in a power drill, and
yeah, well, I did that, and I did that. I don't know if you can see, but I twisted ground and power together with the idea that they would mostly have the same current going through them. So any induced spikes would operate equally on them both. But that doesn't work with the single-ended signals.
Well, your issue is with the signal lines in that one, right? Yeah, because these are single-ended
right.
voltage signals. They're not differential currents.
Right.
So if you hold your cable up again, just hold it across the screen there. So the signal wires are wide open because you got all that area between the ground. So basically the power and the ground look like a low impedance, right? So so you take that area between the signal cables and the power and the ground, and that's going to be a place for noise to couple in. So what you want to do is you want to you just want to twist all four together.
Oh, okay.
Okay. You got a decent number of turns per inch there. I would just twist all four together.
Okay. Thanks for the advice. Yeah, I'll do that. And yeah, I use an electric drill just like someone said. Yeah, it's easy. And
but I don't know enough about this specific bus I2C, but I mean, at some point, if you had too much capacitance, then you won't get clean edges and it won't work. So you can have too much shielding in that way because like a coax cable would probably at some frequency give you a lot of capacitance. So it's a trade-off.
Okay. Okay, thanks. And then the other,
Paul, there's one last thing that before you leave it is that there's also the BNO 055 has an I-squared has a serial port mode too. Just so you know.
But
yeah,
that
Doug,
has the same issue though, because if it's a voltage signal instead of a current, it's a high impedance voltage signal, so it's going to be susceptible to capacitive loads and EMC, noise coupling in.
Brian, you're
Is there
muted.
anything you can get off the shelf that serves as a good cable for a long I2C cable?
Kareem's put something in the chat here on Crosstalk. Yeah. In terms of, you said cables. I don't know, John.
There is a possibility, Paul, if you've got a big junk box, you might have an old serial cable stuck somewhere in your junk box, which would allow you to just use it, and it's pretty as shielded as it can be, and those, in the old-fashioned days of PCs when they had serial ports, a 6-foot serial line was not a big deal. Now the thing is, you're really not serial, you're TTL serial, so
Right.
you don't have quite as much voltage margin. But I still think that that's something that if you have something in your junk pile, I'm sure I still got some.
Yeah, I bet I do. Thanks for that suggestion, Doug. That's a good idea.
And
Also, maybe if you cannibalize a USB cable, they tend to have very thin wires and are shielded and twisted.
that's a good idea.
Yeah, that's a great idea.
I got a bunch of old USB cables if you want them, Paul.
I've got more USB cables than I can shake a stick at.
Single-ended USB cables where one end is just gone for some reason.
Yeah.
Well, I think Doug's suggestion, if I understand, if you're using real life serial signals, then those are considerably more robust than, those are, what are they, plus or minus 10 volts or plus or minus 15?
Well,
Even higher than that, I believe, like 20 volts or something.
That would require something like one of those max 232 TTL to serial converters. But if you really do need to run a long line, we used to run those serial cables all around the building, this twisted pair.
Yeah. And then again, I guess the other possibility, you have to think about this, is you could convert it to CAN. And if it really, long I2C cable runs have a tendency to be noisy and fail weirdly and be very hard. In fact, if you know Scott Gibson, right? Scott, he got around that by going to CAN on his robots. And that's, I don't think that's too hard to do. It is another layer, but it is doable.
And you think about it, the CAN bus is used in a lot of industrial applications and automobiles, so it's made for high reliability.
I figure it runs your car right now. It keeps you from crashing and dying.
Well, Scott told us that he did a study for his company. This had to do with elevators that use CAN bus to see if they're running these long cables inside these high-rise buildings. And they tested twisted pair. They tested all kinds of things, but he tested twisted pair, shielded and not shielded. And he said the unshielded worked just as well. So just twisting the pair was all that was really required.
If you've got a differential signal, I think that's
Is CAN differential? I didn't think.
Yeah, it is.
It is.
Yeah.
And I think I could swear it's a current thing too, because if it's a low impedance, this is the difference between like your headphone jack for your audio, which is a high impedance, and the microphone, like off of a guitar microphone, which is a low impedance. So with a low impedance, it takes a lot more EMF field to induce a current or a noise signal into the thing. When you have a high impedance signal, like we have, I mean, face it, right? I2C was made for inter-chip communication.
Yeah, right.
On a board,
Right.
on a
Right.
board, not
Right.
across a building.
Yeah.
So it doesn't take, it's a high impedance voltage thing, and it doesn't take much resistance or capacitance to load it down compared to like a microphone line in.
Yeah.
And since it's a high impedance, it doesn't take much of a EMF field to induce a noise signal. So the reason twisted pair works is that you figure you've got these wires that are constantly turning over each other. So if you have a magnetic field that's like going this way, the twist in the pairs, well, when it's going through this loop, it induces the current one way, and then a half of an inch later, it's inducing the current through the other way. So the noise from the EMF cancels out, and that's why twisted pair works for radiated susceptibility. I think that's what it's, yeah. So there you go. Just a power drill, tweak it up, get a shield around it maybe, but not too much of a shield.
Yeah, because they got that 400 picofarad limit.
Yeah. And you guys singing the praises of 12-volt serial. I'm thinking when I was looking at that in the early 80s, I did some study on it, didn't know really squat from anything. And I mean, those were the days when 1200 baud was really kicking it, right? I mean, we're in a different world now, guys. Just saying.
Well, also, don't those I2C interfaces have something like a on either end? Don't they clean up the signal themselves?
Yeah, but I mean, if you look at the link that Kareem sent, and I mean, at some point you clean up a sine wave and you get back to a square wave, but I mean, you need a certain amount of fidelity there for it to work, right? So
you mean if the signal is shorter than the rise time?
Something like that.
If I guess, Paul, you probably know this, but if you have shielded cable, it's only grounded on one end. You never ground it on both ends.
Right.
I just want to.
Yeah. Because otherwise you get a ground loop.
Yeah.
Yeah.
And it's like you put the wire.
You just don't want to go that long on I2C. I mean, just you're outside of the design spec of it, right?
Yeah,
so use a repeater if you don't want to like change infrastructure or something like that. But just avoid it or go to CAN bus or something more suitable for the run length you're looking for.
Kareem, are you saying focus the Rube Goldberg actions on another dimension of the design?
Well, so another part of this sort of question, sort of like my wondering about using this BN055 is I haven't used an IMU before, at least in my own work, and has anyone like tried? So these BN055s have absolute orientation because they use the magnetic field of the Earth to correct the gyro drift, but and they have the accelerometer that gives you acceleration. Has anyone tried double integrating that to produce position, and like how well did it work? Did it drift real badly?
It's horrible.
Really?
That's all I'm gonna say. For me, it
I
didn't work.
I can expound on that. It hardly works at all.
Oh, really?
That is a much deeper explanation. Thank you, David.
Okay, I'll tell you though, Paul.
It's got a snowball's chance of hell of working. How's that?
Like on these motion capture for the movies, there was a guy who took a sensor like that of commercial quality, a BNO level quality, and he had it attached. So he had a module you could attach to your foot, and he showed that if you took the knowledge that when your foot moves and it touches the ground, well, when it's on the ground, you have a certain knowledge about its orientation and its movement, so that he would recalibrate the thing between every step. And he showed that he was able to do the double integration trick and estimate the motion of this foot in 3D space as it climbed a couple levels of stairs. But that's a really unique use case, right? And it still wasn't as good as the earlier experts have said. Don't go there.
But pushing on that a little bit, if you don't mind me, because you guys have like played with this stuff, and the double integration with ongoing correction from GPS, from RTK GPS, is a well-known technique in nav boxes. And so I'm sort of wondering, when you say it doesn't work with a dam to do the double integration, what sort of distance or time frames are you talking about over which it would like become worthless?
The problem I have encountered, and I just played with that a little bit some years ago, so some others may have more current knowledge. But the idea is that you're going to look at the output from the accelerometer, and it's supposed to represent what the movement of the cart, of the vehicle, and
Specifically acceleration.
yes, and accelerations are complicated things. It's not like you have a nice clean signal that only changes when the thing accelerates.
Right.
Yeah, and that in a very short period of time, that noise comes to dominate the signal. So you really, even just pushing it in a straight line over a smooth surface, it gets off really fast. Compared to, for example, just dragging a wheel on the ground and counting the rotations.
Okay. Thanks.
Yeah, it's unfortunate because that, when I first got an IMU, that's what I wanted it to do. I thought, oh, everything I need is right here, but it turns out it's not.
Okay.
At least not in their current. I know the ones in submarines, that's how they work. It's a big closet full of equipment, not something you can hold in your hand. So somebody can make it work. But also it may be on submarines because of the medium they're in and the kind of motion that they do.
Well, they're not using MEMS gyros either.
There you go. There you go. The problem may be simplified when you're in the water.
Yeah, and they have better accelerometers.
Yes.
Yeah, you got to go to a completely different accelerometer technology. MEMS gyros are junk. They're good for really coarse signals, but yeah, the error rate is huge.
And accumulative.
Yeah, when you're integrating. Yeah.
Yep.
Hey, Paul, I don't know if you've ever seen this, but this is a BNO 055 on top of I think that's like a 2-foot mast. It's aluminum. Kilohertz. And I'm just looking at I guess it's the yaw angle or the compass. That's basically moving forward, I think 3 meters, turning on alternate wheels, rotating on alternate wheels, and moving back. And
Ray, has the video stopped?
No. Did it? Oh, is it stopped?
And your audio is clipping a lot.
Oh.
Yeah.
It's probably my lousy internet. Is it still moving or still?
It stopped.
It stopped. Okay, let me see if I can rewind it here.
It's doing a good job of making me miss grass. Still got a foot of snow in the yard here.
A foot of snow.
Well, this was not yesterday, Pat.
Oh, okay.
Yeah.
Anyway, yeah. What I was trying to do. Can you see it? Is it moving?
Yeah,
it is.
Yeah.
Okay. What it was supposed to be doing is mowing like we would mow. So you go down one path, and come back. And I want my wife to show those patterns. I don't know if you can see them in the grass, but and I have to turn it off before it runs into the tree. But
obstacle avoidance.
Yeah, obstacle avoidance. So let's see, where is it? Yeah, okay, so there's one loop here and then the next one here where it did that. And so that was kind of the goal. It seemed to work fine. It's just, I just have, using I2C, I just have, BCC ground, SDA, and the clock, and, no twisted pairs or anything. And it seemed to work very good.
Oh, you put 2 feet high. So did you like do any experiments with putting it closer to the motors and observing whether it was affected by them?
Nope. Yeah, and that's kind of why I put it high enough up so that it wouldn't.
Right.
So hopefully there wouldn't be any interference. And
Yeah.
I was what I could do is tell it which absolute angle, like reference to, to the Earth. So 0 degrees was magnetic north, and I actually set it on -5 because that seemed to line up to the way my house is orientated. it's at like a -5 degrees. So so if it ever got too close to the house, it should be parallel to that side of the house. And it seemed to work, very well. It didn't bounce back and forth. It seemed to keep it in line. I had a dead band of boy, I want to say it was ±2 degrees, target of 5. So out of 360. So that seemed to be adequate. It like I said, it wasn't constantly running through the dead band and oscillating back and forth across it or anything. But
well, thanks for the voice of experience, Ray.
So I'm sure other people have done the same thing. So I thought Pat had used it. Pat's still here?
Yeah, yes. I'm still here.
Oh. Didn't you use it on your during the outdoor contest, the BNO 055?
I used it on my outdoor contest. I was using the compass.
Okay. Just the compass, the magnetometer.
Just the compass.
Okay.
Indoors, I'm trying to use a gyro,
and
just to help keep it going straight. And so I'm using odometry and a gyro, and I'm comparing the two. So when I have a rate per loop, I compare the gyro rate compared to the odometry rate. And if the odometry rate is the absolute value is greater than the wheel odometry, then I may take it that it got bumped and try to use that. But right now I have that turned off. Otherwise, I'm using straight odometry.
Yeah, but getting the mowers, I don't know. It seems like those mowers and the other mowers, even like the little push mower that I motorized and played around with, for a mower, it seems to catch the grass in the worst possible ways. It's like the front edge of the mower, it snags on everything, and then the back edge has this flap, and if the flap gets pushed underneath when you're backing up, it can, I don't know, it can just bind and hang on that.
Just fix it in software.
Just fix it in software, yeah.
So an observation, just like we talked about, I think it was last week, in caster wheels, I noticed you have your driving wheels in front.
Yeah.
Mine are in back. Turning wheels are in front.
Yeah.
Those have a lot more trouble getting past an obstacle than the driving wheel itself. If you were driving on your front wheels and using the back wheels to steer, I think you'd be better off.
Yeah, we talked about that last week, and that's I'm definitely going to try that of reversing the direction in which the end that I consider front and making it run.
One advantage of that is if you have to climb over any sort of obstruction, you're now climbing over with a powered wheel rather than trying to push an unpowered wheel over an obstruction.
Yeah.
That even shows up in little household robots trying to climb over a threshold, going from one room to another.
That's my point.
I had one point to make vis-a-vis Paul's question about skinny tires and those being better for odometry. And my only caveat to that is that skinny tires, of course, for outdoor robots are problematic because what you want is traction. So what I've found, and let me hold this up. Okay, this is a tire or a wheel, and you can see that it's actually has an oval profile. So basically, as far as odometry is concerned, it is a skinny tire. And here's a big one. At one time I was going to build a big balancing robot, and these were the wheels. But you can see it's the same thing. That it's an oval profile, but in point of fact, the point of contact, at least on a hard surface, is only about that wide. But then if you sink down into grass or something, you do have a wide enough surface that you can get some traction. The last one I have here, one of these, which we were at one time talking about putting the motors inside of, these are miserable for odometry, both because they're so fat and they're flat across the top, and because they have these huge
grooves. Yeah.
Thank you.
Tread bars. Yeah.
Yeah, they try to grab a hold of everything. Even with that said, these can be made to work if you're using a gyro or an IMU for the heading rather than trying to deduce the heading from the wheel difference.
Yeah, use those for your monster truck rally robot.
Yeah, there you go. These were supposed to be for a big Mars rover. We got 6 of them, and we're going to build the motors inside and everything. Ideas long past their prime. These,
Thanks.
however, are great.
That's all I had, Carl.
This is Sullivan, which builds wheels, all kinds of wheels for radio-controlled airplanes. And what you want to do is look at the ones for quarter-scale airplanes. Those are the big wheels. And they make all kinds. And they're really nicely made. They're solid rubber and perfect robot wheels. So, Mike's Hobby also went out of business, along with Tanner's and every other place I ever went to build robots.
Oh.
They would follow me around, and they would radio in, "Oh, he's stopping at another surplus store. Better shut it down."
Oh, it's your fault, David.
I'm convinced.
The problem is, David, you didn't have your foil hat on, or they would not have been able to follow you. I'm just saying.
Wouldn't read your thoughts, right?
Because I know when I leave my foil hat at the house, I get some really weird phone calls. I'm saying.
Well, I know that the people who do the road construction crews actually do follow me around. And whenever they figure out how I'm getting to work, they'll come back the next day and block it all off. And then I'll find a new way to get loose, and they'll go, "Oh, he's slipping out around the back. Go around and set up cones." And sometimes they don't even block the road. They just set the cones up along the side of the road threateningly.
Oh, well, that's enough. That's enough to get people to really freak out on that deal. Yeah, I agree.
They're clearly following me.
We'll send some tinfoil your way, David.
Well, since we're just babbling randomly, when we went out to qualify one of the arrays in the field, the people from the international agency put 10-file buckets over the GPS receivers to see how the system would handle losing the GPS signal. And when I saw him do that, I said, "You mean that works?"
Carl, after
Yes, sir.
After Harold, I want to bring up a subject.
Okay, cool. So we got Harold next, and then Doug P. Anyone want to go after Doug?
Doug, did you get that John got a gold star? He had a robot.
I got John's gold star for the skull, right?
Yes.
Yes. What about last week? I didn't put any gold stars because I wasn't able to attend.
I put it in the chat if there were any. I've been capturing those, I think.
I think I should have got one because I showed Mobot driving on grass.
Okay. All right. So
Right.
Paul,
That's right.
I'll fix it. You'll get one for last week.
Thank you, Doug.
Okay.
Makes my day to get a gold star.
You can take it home and show it to your mama.
Are you telling me we've got a gold star registry somewhere?
Kind of sounds like it.
It's put on if you go and look at
Put it on Git.
the website for the meeting. So when I update the meeting with the video,
Mhm.
it also lists all the gold stars and the silver star or black stars, I guess. Yeah.
So Kareem,
So-
you know you're in trouble when Paul starts doing the floss for the gold star that he got, right? He was getting close to it, that dancer a moment ago.
We could make that a requirement, you know.
Okay.
A star and a jig.
Jig star. Gerald, I think you had some follow up.
Okay, I got a little follow up. It's not too terribly crazy here. I want to let me come over here and start my my ROS node up. So there's all the ROS node, and yes, we're sending crazy things through that.
Harold, are you presenting, or how should we view?
I'm not presenting. You just want to pin me. So there's my ROS node that's streaming all the stuff that's you can't read because it's going too fast. And if you'll look right there on the right hand side, you can see me in my stuff. So after all that noise that I showed last week, this is kind of the fruition of some of that. I only got one channel wired because I haven't gone through all the works, but what I can do is this. And that's all piping through ROS. This is coming through the standard nodes that that come with ROS built in, that's been configured, going through my Ackerman node, which doesn't do anything but just pass through right now, down to the servo node, which figures out what the limits of that thing can be, and then talking to the servo driver node, which then actually sends down the correct angle to the right thing as I go. So that's all I got really.
Hey, Harold, is this ROS 2?
What now?
Is this ROS 2 or ROS 1?
This is ROS 2.
Okay, that's what I thought.
And then the other servo should work off of the Y direction, but I don't have all that wired up. In fact, I didn't spend a whole lot of time wiring up the channel 1 stuff because it'd just be all hard coded anyway. And so I'm thinking what I'm going to do is I was trying to explain to my Twitch folks, they're like, well, why don't you just use the what's coming off this joystick is a minus to plus 1 that's getting translated into minus 90 to positive 90 degrees as I go through all the translation in both directions. And I might leave it in the degrees, or I don't know at the moment, but I'm thinking though, listening to everybody that's here, that, and they were asking me, why would you do that? I want to make this a vector. So a vector gives me a velocity and a direction, right? So I can use that to then, even though with continuous, I got on or off, I got all that kind of stuff going on, but I want to code it to like I have a choice that I can actually move slowly a little bit versus fast, and then be able to then, from the teleop stuff that I'm getting them plus and minus noise here, translate in that to a velocity and a vector, basically, you know, a velocity and a direction. And then once I then send that down to the Ackerman node, have the Ackerman take that velocity and direction and figure out what to do with all 6 wheels for turning and all that sort of stuff that I got going on. Because I know I can do slight turns because that's the way the servos work. It's just the continuous ones, as Doug pointed out, are either pretty much all on or not. And that's okay for what I'm doing right now. But anyway, that's kind of that's all I got really. Plus all the other junk I was saying. So, ooh, huh?
Cool.
And as far as you're looking at right now, you're pretty much looking at what the Twitch stream looks like when I'm going. I will tell you, you guys were saying it was blurry. None of my Twitch streamers who are very critical about everything else, like Mr. Big Head's a little too loud, have complained about that. So I think what's happening is, time I put this out in a virtual camera from OBS, Google picks it up, does whatever the Google thing does to it, and blasts it up. I think that's where we're losing the resolution on that.
Great.
Anyway, that's what I got. Ooh,
Cool.
Great. Yeah.
That's some kind of star there, right, guys? I mean,
Yeah. I think so too.
it's coming real close to there's a couple of more things I think, but minor things that I want to do. And then what's effectively going to happen is I'm going to pluck the SD card out of this Raspberry Pi I've got on my drive. I think I got to cut a hole in the Zemo to make it work. Cut a hole, pop that SD card out, put this one in it, and then the next in the streams we'll be actually working on the robot to configure stuff on the Zemo, the rover, to do all the various things and start coding on that directly instead of this mock-up that I've got going on here. I think it's pretty cool.
yeah,
I think it's pretty
looking
cool.
good. Especially if you think about all the different things that are
All the
everything
things that are going on,
connected.
and if I'm even half right with what I'm doing, the other robot I got sitting over here is a donkey car, right?
Oh,
It has
that's
a Raspberry Pi on it too. And guess what? I should be able to copy all this stuff, put it in its own repo, fire up the container on this, configure the nodes, because in this point I only need a driving node, a steering. I only need basically 2 servo nodes, one for the speed control and one for the steering. And then it could be that I reconfigure just what I've done here and make this thing work. Could be. In short order. And if it is in short order, then all this prep work and stuff, it's where that pays off, right? There's a little payoff there.
It'll work.
Chris, I've got a related question for Chris. Since Harold was talking about joysticks, I noticed that you use a wireless joystick. Does it work with the standard ROS, Turtlebot type nodes, like the Joy node, or how do you get it into ROS? Is really what I'm asking.
So yes, it can work with the standard ROS joystick nodes, because all they care about in the end is that there's a Linux device, a joystick, right? Because they're all more or less the same on the Linux. He just wants a joystick device. It doesn't really care so much what joystick or gamepad you're using. Now, there are some subtle differences in the button mapping, and I know ROS has a way of taking care of that. So they know the difference between the PlayStation 3 gamepad and other gamepads. But so yes, once you have it connected to Linux, standard ROS joystick
Okay,
nodes
so
will
it
work.
presents as /dev/input/JS0.
Right. Now, I'm not using the standard ROS joystick node. There was one thing I didn't like about it. You had to to control it. You had to keep pressing some other button to actively control it. And I did my own multiplexing thing, right? Yeah. Because what you don't want the joystick node to constantly send speed commands, because then you're constantly in interactive mode. Usually that's not what you want, but I found it annoying to have to keep pressing a button, and only then I can control it. So I just didn't like a few things about it, and it was easy enough to create my own node that's just getting the joystick events from Linux, and it tells me what button or axis it is, and then I translate that into ROS velocity commands, and so I can do my own thing with the multiplexing that I'm doing with the way I'm doing the arbitration and all that. So I just did reinvent the wheel a little bit. But
is that a PS3 gamepad?
Yeah,
Bluetooth?
well,
Yeah, if you'll pin my up, I've got what happens in ROS 2, and this uses a standard teleop twist node, and you'll see
Can't
how
read a thing, Harold.
what now?
Can't read a thing.
It's just
Completely
blurry.
Oh, hold on.
Harold, it's not really readable.
Can you if you pin me, it's not readable?
Correct.
No,
That just blows, man. I'm let me see if I can make it a little bit bigger.
Now, I mean, I don't need a tutorial on the joystick. I'm very familiar with how that works, and
Okay.
I've put the nodes together.
yeah, I'm
And,
using Bluetooth, and that can be a little quirky with the PlayStation 3 one. You gotta do the pairing, and then sometimes it works just like a charm, sometimes it doesn't. So you gotta fiddle with it a little bit sometimes to get it all paired up. And
okay, so there's a
and
little USB Bluetooth dongle that.
no, it's just well, the
Oh, it's
Pi
just
has
plain old
Bluetooth
Bluetooth?
built in, right?
Oh, really? Oh,
I'm using a Logitech 710. This is a little expensive, to be honest, and it has a dongle on it that's already paired to it.
Yeah. I'm going straight into the Pi's Bluetooth. Now, sometimes what I do, right, the disadvantage is that if I drive it down the hall, I'm going to lose signal, right? The Bluetooth
Right.
isn't going to go very far. So sometimes what I do is I run that same node on my laptop, right? Have my laptop sort of be the other end of the Bluetooth link locally, and then the laptop sends out the same commands, right? I mean, again, the ROS doesn't care where the velocity command is coming from. It just
Right,
magically shows up everywhere it needs to show up. So that's one of those nice things. And that way, I end up having a Wi-Fi link from my laptop to my robot that's down the hall,
yeah.
and that's obviously longer range
Right.
than the Bluetooth link.
Right. I want. That's what I want to do because that gives you a lot more flexibility than a wire. And it used to be that sort of stuff didn't work on earlier versions of Linux, but I guess they've made Linux understand Bluetooth joysticks.
Yeah, again, I think most of them work pretty well. The PlayStation 1 can be a little quirky because the way it wants to be paired up with one specific device, it doesn't want to, so that one can be a little quirky, but yeah.
Thanks, Chris, and sorry for jumping in there, but I thought it was sort of like perhaps appropriate.
This is the remote that I use. And now it's not a long range device. I have 3 buttons, left, right, and whatever you want the middle to be. But these can be bought in pairs with the transmitter and the receiver from lots and lots of places. This one is, Southern Methodist University. Well, we'll just put that aside. I can't remember the company name.
Thanks. That was what I was looking for.
Yeah, they're like garage door openers, right? Or you can use them for that, right?
Yeah, exactly.
Yeah.
And actually, the one that I use for the outdoor robot, I've been able to send it signals, a couple hundred yards. That's
I think most of them work at like 433 megahertz or
I
something.
think that's right.
Yeah.
And you have to pair it. You have to hold a button down and pair it when you first set it up.
Yeah, I think you really want the gamepad kind of style though, because you really want that joystick to be able to control speed and vector.
My problem with that is because I have flown and driven radio control airplanes and cars with very expensive precision, wonderfully gimbaled sticks, that I find those things really crude. So if you're going to be crude,
Binary. Go binary.
Basic bang converter. Yeah.
Cool. All right. Well, thank you, Harold. Good encore performance there. I think, Doug, we had you next. Doug P. Very
Yeah.
D.
Here we go. Give me a second. Okay. I'm here. The thing that I want to talk to everybody about is, it's March 22nd. And we haven't had our springtime competition. It's time to start setting that up. Now, also, so I want to ask people if if you go out to the website and let me do a little. Okay. On this page, which is dprg.org/contest rules, are all the contests that we have rules for. And we need to pick a subset of these that we're all going to support and try to have a robot that will run on it. We've already got one there that the sample retrieval one right here. That's the one that we're going to have for Kareem's team and anybody else who feels they can get some AI work done. So that's kind of going to be the hardest one, I believe. So Kareem, are you there? Can't see. Hold on a second. Kareem,
Yeah, I'm here.
Okay. So there we go. Those are the rules right there. Okay.
Yeah, I just need to figure out how to get more samples of those targets.
Okay. Well, except for the Smurf, the rest of them should be pretty easy to obtain because they're just the.
Yep, the Smurf is the one I'm worried about.
Yeah, and if you go out if you do the images on the web, there's a gazillion Smurf images. So that would be one way. The other way is I don't know how we could hook it up, but I could send you a Smurf. That's the other. I could send you the Smurf. Okay.
The Smurf.
Well, I have two of them, so I can send you one, and
we could create an image database for it.
Yeah. Okay. So offline, maybe in a separate email, if you'll send me your address, I can put it in. I'll put the Smurf in a box and send it to you. Okay.
Sure.
All right. Okay. So that'd be one. We usually like to get. So let me ask you this. Let me switch back to the group here.
It feels very strange to have a contest allocated because somebody's willing to do it.
Well, it's much worse than to have a contest and nobody does it. And nobody does it. And you're actually breaking ground on this one. Okay, so think of it that way. You're breaking the ground.
We haven't run it before?
We've never run it because we've never had anybody who had the skill to run it. Okay.
Well, now that's making it sound like a challenge.
Yeah, okay. And like I say, we can make it, for people who don't know, basically on this contest, there are 5 objects. They're like a Diet Coke can, a child's block, a baseball, a Smurf toy, and something else. I can't remember what it is, but 5 objects. And you start off in a block. You start off in a square, which is your home base. And then the rest of the room, of the contest room, the 5 objects are placed. And you're supposed to go grab the object, find the object, grab it, and return it to your home base. So that's the basic contest. It was viewed originally that what would happen. Okay, let's see. Okay, so I think I've stopped it.
Doug, I took over because you were showing something else, but
that's fine. And so the intent would be that you can make it as hard as you want to. Probably for the first time, we depending on how confident Kareem's team is and what sort of search pattern they have, we can either keep them inside of the home base or we can actually place them in the room in random spots. So there's some wiggle room on how the contest is set up. But the other contest, I know the people that are that are remote. We're going to allow this to be run remote. So anybody who can find a place to set up their robot and do their robot run, they'll be considered to run the contest, and they'll be in the remote group. Okay, just like we did for the last contest. So people like Pat and anybody else who's out of town, they can set this contest up, video it, and so ideally while we're in the contest, but if not, whenever they can submit it, and then they'll be run as part of the contest. All right, so now the question is, we usually start the contest off with simple contests. So some contests that fit that criteria are four squares, quick trip, four corners and quick trip, and Tabletop Classic. So those would be three possibilities that we could do for one or two of them for simple. That way they're very easy to set up. Then we can go into the more complex contests. So does anybody here want any specific contests? There's people here who know what the contests are and people who don't know what we're talking about. So what I'm suggesting is, if you'll go to that page on the DPRG website, under the competition tab, there's something called contest rules. If you click on that and look at the contest rules, and if you see something you like that you think you'd like to run in, next week we'll talk about it and see if we can get a list of contests, okay? So it's on the DPRG website under the competition tab. Ray, you up for running can soccer or can whatever the other one is? What is the other one?
6-can.
6-can. You want to run a 6-can?
I haven't done anything with that in a while. I assume it's still.
Would anybody like to challenge? How about you, Paul? You want to try the 6-can, John?
I'm about to start traveling for till October,
right.
So.
Okay. All right. Anyway, I'd like to give it some thought so that we can get set up a competition. Be indoor only this time. We'll probably have 3 or 4 competitions, and try to get some robots on the floor and running against each other, and we give cool prizes.
Doug,
okay.
What date is it set up for?
Well, that's what I'm going to talk about.
Oh,
it is already the end of March. That's usually, we'd like to have at least 3 months. So that would probably mean June.
That sounds like a good strategy, but let's think about it this week and do a lot more talking next week.
Yeah, right.
That's my
But
thought.
I want to breach the subject because, at least for me, competitions are some of the coolest times when we get out there and really go out and try to actually do something. And so anyway, let's think about it. And so we'll probably be the second week of June, would be probably a tentative date, and on a Saturday. And I'd like to have a total of maybe 4 to 6 contests, and at least have 2 people run in each contest. And I know on some of the easy ones, we can easily have 4 or 5 people. And Carl had the last success, one quick trip by not turning around. Now, the question I have to ask you, and I know this is going to, should we make people turn around, or is that still a viable strategy? I'm going with it's still viable. Okay, so
Seems like the whole point of Quick Trip was that it was the most rudimentary contest we could think of.
Yeah.
Drive in a straight line and drive back.
Yeah.
And that although there are many, many challenges to be dealt with before you can get to that point. So you may remember, Doug, when we were, or maybe you don't, when we were over at the science place, somebody ran that by just having a stick that stuck out in front of their platform, and when it hit the wall, it reversed the motor.
Well, I remember some of the other tricks people did, like the can where you had to get the 3 cans off the table, where somebody just had one that just cleared the table as it went to the end. People have tried all sorts of different things over the years.
I remember one guy showed up with a leaf blower.
Oh yeah, I remember him too. He was anyway. But
one year or another, didn't Real build something where he didn't have any? It was all mechanical robot type thing where it would just wind it up and it would click some lever and then would go back.
Yeah, hit the wall and then
reverse the motor. There was no
so
electronics involved.
So we're going to still allow the straightforward and straight back. Now the obvious advantage of that is it takes time to turn around. Okay. Now, personally, I still like to go out and turn around and come back, but I can see the advantage of allowing people to go straight out and straight back.
I would allow it.
Yeah, me too.
Keep it the way it is, because my goal for that one is, I mean, why do it easy? I want to do it where the robot's pirouetting the whole way.
With obstacles.
Yeah.
Okay, now I don't know about that. That's a bridge too far.
I've been working on that. I think, Carl, you and I are the only ones who have robots that can navigate while rotating.
Exactly.
So what I've been looking at lately is I also want to be able to do obstacle avoidance while rotating. So I spent a lot of time thinking about this. And I think the right way to do it is you have to know the heading of the robot when the sample was taken so that you'll know which ones to look at. And I'm thinking a little bit about how to do that. It might just be as simple as just, having some range of headings that you look at the sensors during that time and you don't look at them the rest of the time. But I think that would be cool.
I don't know what your current membership is, but I think is it also an opportunity to grow the club a little, generate some interest, have spectators?
Well, anybody is welcome to come, okay? And we've had different things in the past, but because of COVID and where we are right now, I think just having the competition would be an achievement for this spring.
Well, I mean, beyond just anybody can come, but actively advertising it and letting people and having participants show up, at the club. I mean,
at least I've done that in the past few years and I know others have as well, to go out and try and publicize it and bring people in. And I don't know, to my sense, it's brought more spectators. In a way, the online YouTube channel and such have brought more Meetup and YouTube. It brought more regulars than.
Yeah, John, I guess my thought is, yes, I'd love to do it. I personally don't have the bandwidth for that. There is quite a bit. I mean, even on these simple contests, when you're doing it, running a competition pretty much takes one person or two people completely to do it, because you have to keep track of who's running, when they're running, and everything. But if you have any ideas, I would, yeah.
Well, it depends on where we have it. Like if we have it the makerspace, we can put it on the counter and people look at that counter more than you might think.
Oh, yes, that's true. So, well, it definitely will get on the makerspace calendar. So that's one of the things we need to do and set that up. And then we got to go clean that, make sure that room's cleaned and everything. So, but I just want everybody to give it some thought. Take a look at the contest. If one catches your fancy, people that are remote, if they can look at those and see, well, hey, I don't have the space for this one, but I have space for another one. We can go ahead and they might want to pick one like that. One real challenging one, the Tabletop Classic, if I remember right, is pretty simple. The robot has to drive to the end of a table and then come back to a certain line. It has to knock a can off the table, and then it has to put a can in a box, if I remember. If I remember right, that's what the rules are. The tabletop, big tabletop or tabletop 2 or whatever it's called, has a much, you have to take and knock three cans off you have to knock 3 cans into a box, and then you have to line up 3 cans in a line that are within a yardstick and in a line. So it's much more complicated, and it's a good challenge, and it doesn't take a whole lot of space. The Tabletop Classic only requires you to have a standard folding table, basically. So any place that has a folding table, a standard one that you can sit 6 people at, you can run the Tabletop Classic.
Sounds risky to the robot.
Depends. It depends on how cool you are. Like I said, if you're hovering around the edge of the table the whole time, less danger to the robot, but more you don't look very cool. But if you can and if you have confidence in your robot, just let it roll, and it rolls. Just that I will say this: don't make it out of plexiglass.
Do you speak from experience?
Oh yeah, I had a robot that started out at 100% plexiglass, and by the time of the contest, I think it was 60% wood and 40% plexiglass. And every time it fell off, it would break apart. So
did Chris just sign off?
I think he did. Yeah.
Reps, I wanted to ask him, there was a strange blue and black box which appeared to have antennas and a cable running to it on the wall next to his desk. Did you guys see that? What is that? Chris, what is that?
I'm assuming it was a router.
You think it's a router?
Yeah, I don't
Mounted up there on the wall so the Wi-Fi could get good coverage.
Yeah. Anyway, please take a look at it. And also, we all been looking at the infrared laser array type sensors. Well, it turns out that a new one has come out, or newish to me at least. Let me see if I can get to this again. Sorry, guys. This one is a little pricey. It's in the $60 to $70 range right here. Okay, and it's by broadband. All right, Broadcom, excuse me. And here's if you take a look at its specs, there's a couple of things here that are really kind of exciting. It says operation up to 200 kilohertz, Klux. That probably will be able to do in bright sunlight. And it has a range up to, I believe it's 20 yards or 20 meters at a reasonable speed. So anyway, you might want to take a look at the AFBR-S 50LV85D.
Carl, are you typing that into the chat?
I'm trying to, yeah. Yep. 9.
Doug, this is an array or a single sensor?
It's an array. Now, I don't know how much, I don't know exactly how they, the ones that ST ones, a lot of them, they are an array, but you only get a single reading. You can't get individual pixels. And I'm not sure, I haven't read through everything on it. Here's the array. You can see it right there. And
That's the transmitter array or that's the receiver array?
I would assume it's the receiver.
Well, if you scroll back up a couple of pages, one more, stop.
There.
Yeah. The transmitter is aligned with the receiver to illuminate typically 1, 2, 3 pixels simultaneously, depending on the distance and reflectivity.
Right.
So it looks like the resolution of the array for the transmitter is not the same as the array for the receiver.
Yes, and it might, and like I say, it could be something like, again, just thinking about it, it might be something like a sharp sensor in the sense that you get a number based on what 3 pixels are, illuminated, because it is a paired distance. So anyway, it's kind of interesting and very fast. It says it has 32 pixels and it has a range up to 30 meters and beyond. But
that's pretty impressive.
For what we all know, that when they say 30 meters and beyond, they're not really talking about beyond. And
yeah, they really mean 15 meters.
Yeah, right. So, but even so, that's still thing. So, like I say, it's a little pricey. It's in the $60, but it might be something that would be a usable idea. All right, so that's all I wanted to show there.
That's pretty cool.
So what are we going to do? We're all going to look at the contest rules and find something that we would like to run. And we'll and we'll be shooting for the second week of June right now. Okay? Yeah.
It's in the notes. That's as official as it gets.
Yeah. Harold, you wanted to say something? Okay. All right.
Good job. Thanks for running with this.
There it goes. I was trying to figure out dependency injection off interfaces going in with stuff for a Twitch bot. And that means nothing to nothing. So there you go. Party time.
Thanks, Doug.
Yeah.
Okay. Well, I have something. If somebody wants to think about who wants to go next, it's not really robot related, but at least I know some folk in the call like optics and photography, and this kind of sits in that world a little bit. Come on, sharing. What's wrong? How about this? Somebody has come up with an acrylic plate with some kind of lens structure that I don't know what it does with the optics, but the video is pretty cool. It appears to be a invisibility shield. So you just put it in front of yourself, and what happens there? And it's all passive. So anyhow.
I wonder at what angle the observer has to be for it to work properly.
Yeah, because all of these are straight on, right? But yeah.
Oh, now there's an idea.
Yeah, in the middle of a bike trail. There you go.
So can we just get some clothes made out of that?
It's that's cute. You can for $65 you can get a like 8.5 by 11 sheet or something. The big sheet that they're showing they want $600 or $700 for or something. But anyhow,
Boy, that's cool.
That's pretty amazing.
Yeah, I thought this was a group that would enjoy it if anybody, since I don't have any robot things to share right now.
Screw it to the car. You could save a lot of speeding tickets.
Oh my goodness, there wouldn't be any dents from that, would there?
Not being
Way to,
seen.
way to get rear-ended.
Pay no attention to the empty space in front of your car. All right. Okay, so that's my distraction for the night. Ooh, that's something else. Anything robot-y else? Anybody?
I've been making brackets, so machining. I left them all in the garage though, so I don't have anything to show. But I was trying to make it. It's aluminum angle iron that's 2x2, and I was cutting them off with a bandsaw, and then machining both surfaces so it's parallel. Then I have to use that as a reference to machine holes and retainer screws for a bearing, and screws, screw holes in the bottom so I can bolt it to something. And that's to replace these, which are very heavy. These are like 27 ounces, and the plate that I'm machining is only about, it's around 2 ounces. So, but I would have to use 8 of these, and it kind of makes the whole platform too heavy. So that's why I'm machining the aluminum angle brackets that hold a ball bearing. So that much lighter.
Yeah.
Those look like nice bearings, though. They've got little oil nipples on them and everything. They look really nice.
Oh yeah, grease zerks. The yeah, what's kind of neat about these is that they'll tolerate like misalignment. So this could be, kind of off in any direction, and the bearing actually spins. I don't think I can do it by hand, but as far as misalignment, it's in there pretty tight. But that actually will swivel around inside this housing to accommodate misalignment in all directions pretty much, and still support it. And so yeah, they're kind of neat. It's just a pillow block is what they're called. But I was kind of in a hurry, and I don't think they said what the weight was, or if they did, I wasn't paying attention to it. And it's like, okay, well, I'm just going to order these, and I did it. And then they came in, and it's like, I pick up the box, and it's like, whoa, what is in this box? 8 of these things. So I don't know. One of the things I probably should have paid attention to, but didn't. And I guess I'll use them for something else at some point. But
So Ray, a few weeks back, you showed a video of your lawn tractor driving itself. Are you still working on that?
oh yeah, what I've done, I've gotten. I can go get them and show you if you like. I'll be back. Hold on.
I didn't mean to send them off.
Great. That's what we're doing here. Somebody's talking, and then we say something, they just disappear for a bit, and they come back.
Harold had to talk to his wife.
Well, that was a good excuse. Yeah.
Yeah, that's usually a real good excuse for a whole, I'm
First
sure most
reason
people
why.
would know exactly why that would be. Yeah.
Especially after days of absence.
Yeah.
Yeah, what I've gotten, these are, those are the 10-inch brakes that fit on a 1-inch shaft, which is what the differential on the mower has. And these are mechanical brakes that basically you can,
Actually,
I'm just going to servo. So they have a mounting brake. They, the disc fits in the center there. Those two shoes are pushed together right now. But basically it fits in that gap, and this lever either pulls them, well, it just pulls them together basically on the disc that rotates through this slit. And I'm going to do, instead of Ackerman steering, differential steering. So either one side is braked or the other side is, I'm applying braking on the differential, and that way I can steer. I'm just going to have two casters in the front, and I've got narrower wheels. The wheels that I have on there now are about 8 inches wide in the back, and the ones that I'm replacing them with are about 4 inches wide because I only have so much axle length. So if I put a disc brake on the axle and another wheel, well, there wouldn't be enough room for the disc brake with the current size tires. So I had to go to smaller size tires, which are about 4 inches across versus 8 inches across. But see how that was.
Oh, a lawn tractor
also,
with disc brake. That's you're planning on going really fast.
What's that?
A lawn tractor with disc brakes. You're planning on racing this thing?
Well, no, I want brakes because to get it to turn, I have to lock one wheel on one side of the differential, so the other wheel is driven.
Yeah, I get it. No,
And
sorry.
yeah, so now it's not going to go faster than it normally would. But Go Power Sports, that's where you can get all this kind of junk. So
cool.
And then I'm playing around with a 4-wheel drive platform too. That's going to be driven by wheelchair motors. So it's just going to be like skid steering, just to kind of which one works the best. I know the big tires in the back of the lawn tractor work pretty good. Pretty much go up and down any grade that I need it to. That has excellent traction, but it's Ackerman steering. I don't know. It's not very robotic like, so that's why I wanted to experiment with the the brakes on the differential, and you can use that on pretty much any differential, like the wheelchairs that have just a single motor and a differential. You could steer that with brakes, just like I'm trying to do it. Brake on one side or the other to get the thing to rotate, in that direction. But I've always wanted to play with a 4-wheel drive platform, and just to see, if it worked that much better, or kind of what the characteristics of it are. And
cool.
Shouldn't, if you can't mow your lawn with a 4-wheel drive mower, you just can't mow your lawn. So,
Four-wheel drive self-driving mower.
Yep, 4-wheel drive self-driving. Yeah. I wanted to, it's like all this stuff, it's using gas engines, and you think of, okay, maybe I should be going all electric. And I've had an extra solar panel that I haven't used for anything. It's just sitting up in my garage in the attic space, and it's a 230 watt panel. I thought to be like totally green, I should use that as the power source for mowing and locomotion, and it wouldn't have to mow very much. Each day the sun would come out, charge two little small batteries, and with a 200 watt panel, you probably get about 200 watts out of it. The Texas sun.
Yeah, well, It can't be that big. Just mount it on the robot.
The panel? Oh yeah, the panel's huge. It's like, I don't know, I think over 3 feet in one direction and about 2.5 feet in the other direction.
Yeah, you got a big mower. It'll balance.
Yep, yep. So,
And you could cut forever. It just as long as the sun's out.
Yep, yep. So, and when depending on where you're mowing, you want a little stored energy there because you go around the shady side of the house and the output of the panel goes way down and so you got to have it get it back to the to a sunspot, but yeah, that's the other thing, Carl, you're restoring that old car. It had no
What?
devices on it. I'm putting a diesel engine into an old truck. It has no anti-pollution devices on it, so it's like, oh my God. So I have to kind of offset that and think, okay, do something that's all electric. Supposedly these little small engines like on lawnmowers and weed whackers are some of the worst polluters. They're saying like the 2-cycle engines that they used on motorized bicycles put out more pollution than a pretty good V8 does, because it's all hydrocarbons, just
A lot of that's just raw fuel coming straight out the exhaust that never got burned.
Oh yeah. Hydrocarbons are some of the worst greenhouse gases, unburned hydrocarbons, and it's like pumping methane into the atmosphere. That's supposed to be one of the worst ones.
So you would end up like
I do that. I don't know about small engines, but I do that every time I pull my finger. So I just don't know about all those things. So
Yep. Cows as well. We should get on a. That's why McDonald's introduced the McPlant. They're concerned about cow farts.
So Ray, you're going to end up with something. You have a solar panel somewhere out there on your property set up with a charging station and an autonomous lawnmower that sits there until it's charged, and then it goes and mows the lawn and comes back to its docking station and reattaches, all with no intervention from you required at all. You could be out of town or have passed away.
That's right.
Right?
Or have passed away.
Yeah, anthropologists, thousands of years from now.
That's right.
Find this machine dutifully mowing the lawn.
Yeah.
David just cuts the quick on that one right there. He just.
That's not very nice, David.
It'll be the only sign we were ever on this planet.
Exactly. Once it's autonomous enough, we're not needed anymore.
So you're telling me Ray is going to be responsible for making Wally? Just saying exactly.
Yeah.
I think that anthropologists 5,000 years from now will dig it up and watch it work, and they'll say, obviously, it had some religious significance.
That's right.
Because all it did was mow the grass over his grave, so it was really well kept.
Yep. Yeah, actually, I wasn't going to use it to, the solar panels as stationary. I was going to put it on the platform. So wherever it drove, it took its power source along with it.
You just sit there and charge up.
Yeah. So when it ran out of juice, it'd sit till it had enough juice and go a few more feet and go. Is that how that works?
Yeah, it's just going to have some, small batteries to get it through areas where there were, like shade.
You should just move your lawn under the robot.
You could do that. Yeah.
It's all relative.
Yeah.
Like those 3D tables.
Or wait for the sun to, like later in the day where the shady areas would have sun then, and then,
Either of those ways would be a gold store. That's you can move
definitely gold
the
store.
robot.
Well, how about the traditional high school kid with a lawnmower? They're cheap.
Too expensive.
They don't follow instructions very well.
Well, unlike your robots, Kareem.
Admittedly, that's a drawback.
So how about a quick question from a non-electrical oriented person? Ray mentioned that he would have his solar cells in line with his charging to charge as he was running. And I've thought about that, and I don't know, does that just work, or do you have to do something special for that? To take circuits? How does the battery know to charge or put out energy to the battery?
Oh, yeah, you have to have like with any solar panel, you have to have a maximum power point tracker. So you have to apply, to get the most power out, you have to apply a certain load to the panel. So, and all solar systems do that. They apply a load to it. So
But
there's
the robot can be driving while it's charging?
Oh yeah, you can get like they rate the panels for it's like 1,000 watts per square meter, but in Texas we don't get that much insolation, incoming sun energy. It's a little bit less, and the further east you get, the worse it gets. Out in out in the desert, you're going to probably get the 1,000 watts per square meter, but certainly not in our area.
Ray, you're not answering Doug's question. Yes, you do have to have quite a lot of pretty sophisticated electronics to do charging while consuming. I've looked at that.
That was my question.
I've looked into that for my RV. I have not implemented it, but with any kind of lithium battery, you would always have a battery management system, a BMS,
right?
That sets upper and lower bounds on what the battery voltage can be, but on systems that have solar and like RVs where you've got solar charging and simultaneously discharging, they'll have a charge bus and a discharge bus with separate relays or contactors to connect either or both of the load side and the charge side. So if the batteries get full, then it disconnects the charge side. If the batteries get too empty, it disconnects the load side. But normally when they're in the middle, both can be connected, and the charging source, be it an inverter, a solar, whatever, feeds the load plus charges the battery.
The battery, right?
If you really get sophisticated,
that's not me.
Victron makes a wonderful device that I would love to have for about $1,300 that can take shore power like two-phase 120 plus solar, and then the batteries, and then the load. So there are 4 ports on this thing, and so it'll draw from the solar and use that to charge the batteries. It'll draw from shore power if shore power is connected, and also charge the batteries and run your load. But if you disconnect the shore power, then it just feeds off of the batteries. I mean, it's a wonderful device, dynamically switching between sources. But so that's the sort of sophistication that you really want to get into if you want the sort of thing that you're imagining.
Yeah, I'm imagining that Adafruit makes that for $29.95. I guess that's not true.
Well, they have that
She
big
might,
solar
actually.
in Australia every year, and I've never looked at those cars closely. They all kind of look like armadillos covered with solar cells. But I wonder, do they really just drive directly off sunlight, or do they actually have intermediate batteries that they're charging, and they're actually running off batteries charged by sunlight? Does anybody
They
know?
are allowed to have a small capacity battery to help with starting torque and things like that.
Batteries weight, batteries drag.
Yeah, but if you have some money, you can get some lithium iron phosphates like Battleborn makes some really nice ones that are like 50 amp hour, 24 volts for about $800. That'll last like 7,000 cycles. So
Yeah, I put lithium LFP, what you're talking about, lithium ferrophosphate batteries in my RV. I built them up from cells. the trouble with what you're talking about, the battle-borns, is that drop-in lithium. They're marketed as drop-in, but you really need to design a lithium battery system as a system. You can't just drop it in to, well, you can drop it in where you put a lead acid in, but you tend to have, there are some difficult issues to deal with. So I ended up building one out of 4 raw cells, 280 amp hours with a BMS, but some of the issues you run into, and you're right, Battleborn is like the leader, the top quality leader in the space, in the drop-in space. But the problems you run into is that you really can't parallel them properly, because the different BMSs they'll be sucking charge. They each try to suck in their own however much charge they want, and they aren't like balanced necessarily, because it uses a built-in BMS. It typically uses MOSFET switches to disconnect the batteries. That limits you in the amount of surge current that it'll supply, and so it is possible to blow up the MOSFETs. There are a bunch of issues with drop-in batteries, and also charging them can be an issue, because if you're charging them and like off of a car alternator, and then they become full, and then the BMS disconnects the battery, well, all of a sudden your load has been disconnected from your alternator, so you get a big old back spike that blows up the alternator. And so that's why you really need to design a lithium battery as a system. Sorry for going on a rant there, but I've delved very deeply into lithium battery systems before I designed mine.
I appreciate the input. I figured it was complicated.
And Paul, it seems like, because I haven't gone as far as you, but just from reading things, it looks like there's any number of different subsystems available. So you can get the chips that they build into laptop battery packs. You can get the energy management circuits and such. You can buy the off-the-shelf like solar charging battery pack things, and some of those will charge and power at the same time. But it seems like there's not really the kinds of modules that would make it easy for us to just mix together and piece into our robots, right? Because it looked like you had to go through some machinations. It was hard, if I remember, for you to find the modules that you put in the Mobot for your power architecture.
I wouldn't say it was hard. No, I wouldn't say it was hard. It was pretty straightforward. It's just you can kind of see it.
So there was a number of different options for the different elements. It was easy. It wasn't too bad to come across and piece together.
No, not so long as you recognized what a lithium battery with BMS is. It's a thing that will disconnect itself when the voltage gets too low, and when the voltage gets too high. And if you live within that parameter, then.
But wouldn't okay, so your lithium iron phosphate battery is going to have like a certain discharge rating. So the BMS is going to protect that if it goes over that. Say, you accidentally short it out or temporarily short it out or something.
Hopefully.
Hopefully, yeah. Hopefully it's really designed well to do that, because that's what it's supposed to do.
Adding all of those things.
I don't know. I would say just as long as you don't exceed the ratings of your battery, which includes in case of the Battleborns, you shouldn't blow it up or do things that would harm it. I mean, you know, as far as charging and discharging it at the same time, things like that. Wouldn't it should be rated to protect that, right? Because it's going to only accept a certain charge rate, only accept a certain discharge rate. It's going to try to balance, you know, all the individual cells in the battery. Otherwise, it's, you know,
the kinds of corner condition cases you have to worry about is, as you know, BMSs will disconnect when the batteries go over 4.2 on a LiPo or 3.65 on an LFP. So what happens then? You're charging away and you're drawing a small amount of current out of it. Then it reaches 3.65. The BMS disconnects. Now your load's disconnected, but then it wants to draw. You want to draw power, so then it reconnects. But you're charging power. Maybe your charger isn't supplying all of the power that the load wants. So, you know, it seems to me there are a lot of issues that are more complex than just slapping in a lead acid battery.
Yeah, I guess if you could look at that, I guess one of the things that I guess I could do in that situation is run the motors at a slower speed, you know, like to maybe limit the load that it would see. So in essence, controlling the load versus, you know, letting it do whatever it wants or accelerating quickly or things like that. So yeah, I don't know. I guess I'd have to look into it. It sounds like you've investigated that quite a bit already. But
all I'm saying is you need to, with lithium batteries, you need to consider the charge and discharge and the battery as a system, and consider all of the operating corners of the thing, from discharged to charged and charging and discharging.
Yeah, it's like simultaneously. Yeah. Like load conditions. Yeah.
Yeah. I mean, with Mobot, it was, I'm not trying to charge it. So it's just it's pretty simple. It's I'm not trying to charge it while it's running. Actually, that's not true. I am charging it. I do charge it while it's running. But the charger has enough oomph to drive the load once the BMS disconnects the battery. So yeah, so it works for me, but I'm saying it may not work in every case for all types of loads, all types of charging currents.
Yep, scenarios. Yep.
Yeah. So.
Yeah, I mean that's for me, that right now is the pie in the sky thought. You know, haven't even started to do any of the design. So, but yeah, I don't know. I have to think about that. I kind of wonder if you could.
Yeah, I've got a Dally. I've got a Dally BMS in Mobot, and I've found through experimentation that it goes to sleep after a while and disconnects the battery. So, and that's if there's minimal load on the battery. And then if you put a load on the battery, enough of a load, like pretty minimal, then it turns back on again. So but it does have a certain amount of self-discharge, you know, because lithium batteries by themselves will hold their voltage forever. But I find that with the BMS connected, it sort of loses a few percent of charge, probably over the course of a few days. So it's the BMS is drawing continually to sort of like live in that sleep state while it's waiting for a load to be applied to reconnect, so that it would reconnect the battery to the load.
Yeah, I don't know if there's a way to do it like considering what the BMSs are trying to do, like to, you know, maybe if your batteries are close to fully charged, you know, try to run off the solar panels mostly. And then when that source dwindles, say it goes under a tree or, you know, in a shady spot or something, you know, could you slowly transition over to, you know, the battery supplying the power, you know, just temporarily. And then when you come back into sun, you know, kind of look at it as you've got two power sources, either the solar panel or the battery, and slowly transition each one back and forth.
And so you want
Don't know if that's possible.
Yeah, it definitely is, and you'd use a charging a load sharing, like one of those ideal diodes that I put in Mobot, would be a way to do that. So you share the load, and the load, you know. In fact, I'm doing just that because my charger is downstream of the load of the diode, and so when it feeds the electronics, perfectly can run the electronics indefinitely. But when I crank up the motors, that draws more power than the charger can supply. So the charger, so the battery backs it up, and the BMS will turn on, connect the battery, charge starts flowing through. But it all needs to be pretty quick. You know, there's no slow switching, or your voltage will droop.
Yeah.
Paul, remind me.
I was thinking it, you know, as far as motor speed, if the whole platform slowed down a little bit during the transition, you know, no big deal. I mean, you've lessened that big jump in load, so
Yeah, that's true.
Anyway,
Paul, remind me, the ideal diode circuit that you showed us is basically a FET with a switch on the FET, basically.
The FET is there's a pair of transistors that turn the FET on or off, and when the cathode side of the diode goes lower than the anode side, then it turns the FET on, so you get like milliohms of forward resistance and no voltage drop. And then when it reverses, then the FET shuts off.
kind of like a high side switch, I guess.
Well, yeah, so basically it's using a pair of transistors to sense the current direction.
It actually senses the voltage difference between.
Isn't that the same? No.
I thought you said. Say again what you said.
I said, isn't that the same? If the current flows from the higher voltage to the lower voltage, right?
Oh.
So the electrons are going.
Yeah. If there is current flow, is really what I was saying. Because
transistors are telling you which way that's flowing, and based on that, they're switching the FET off and on.
Right.
Cool.
Very quickly.
Yeah, it's a pretty cool circuit, and apparently quite widely used for power sharing.
I don't know exactly how it's done in the phones, but it must be similar because, you know, the phone just won't work if it doesn't have enough charge. And part of that is because to get the maximum power out of the cellular antenna, it's more power than you can get off your typical charging circuit. So it has to, you have to have enough energy in the battery so that even if you're using the phone while it's charging, the battery can take care of the instantaneous bursts from the RF power amplifier. So it's using current, it's drawing current from both the battery and the charging circuit to operate at certain parts. And in fact, that's where, like, some of the old designs we did at prior company, the wires between the battery and the phone. I mean, it couldn't have wires. It had to be like right there. Because the resistance of the wire and the contacts was enough to give enough impedance that the power amplifier wouldn't work correctly. Because it'd be a big voltage drop in that huge current surge.
Instead of wires, you had to have bands, right?
Yeah, flat,
Little bars.
nice wide, flat pieces of copper plated whatever, or
Yep.
whatever plated copper. I don't know.
Anywho,
Alrighty. Well, we've had a handful of folk drop off. Is there anyone else who would like to speak up before everybody vacates?
nope, not me.
I think we're running dry.
I'm
Well,
done.
for what it's worth, Pat, check the thing in the chat here. Pat's interested in Four Corners. So Four Corners in June.
Cool.
And other than that, we'll see you all next week. Have a good week, guys.
Good night, guys.